All right, everyone. This lesson is a quick recap of what the derivative is and then the two important formulas for finding the derivative before we get all the shortcuts. So these don't come up a lot in the class, but they do come up on the AP test in certain ways, which I'm going to show you at the end of this video. And your homework number 4 has one that you need to know how to interpret. But before we do that, let me remind you what the derivative is. All right, so check this out. I programmed this in Desmos. Let's say I wanted to find the average rate of change of this function, this is f, between 1 and 3. Well, I would graph the point at whatever x equals 1 is. It looks like it's 1, negative 1. I graph the point at 3. It looks like it's 3, negative 3. Connect the dots, and this is the secant line. So right here you have a secant line that is showing the average rate of change. So look, it's steeper and then it's shallower, and it's actually a positive slope here, but overall this is the average rate of change between these two. Now, what the derivative does is it wants to find, or the derivative is, the instantaneous rate of change at an instant. So I go way more into detail on this in my old videos from AB. This was the big focus of AB in the very beginning. The derivative is the slope at this point. So I want to find, if I were to zoom way in on this point, you see how this is practically becomes a straight line? We're going to essentially calculate the slope of this line. That's otherwise known as the derivative at this point. You almost can count the rise over run. So look, 1, 2, 3, 4, maybe 5 over 1. So it looks like the slope here is about 5 for this function, about 5. So what the definition of the derivative does, it says, okay, the average rate of change is found by taking the slope between 2 points. It's y2 minus y1 over x2 minus x1. The only thing that's different about that and the derivative is the derivative says, okay, let's do the same thing, the slope between 2 points, but let's just get those points super close together. So look, for example, if I got to 2 and I found the average rate of change between x equals 2 and x equals 3, that's a better approximation for the slope right here. Look, it's getting closer to what this actually is. If I were to go to 2.5, look, that's even better. That's a pretty good, the slope of this black line is pretty close to what the slope of the curve is right here. And I can keep doing this. I can just keep making the point closer and closer and closer. Not 3, 2.9. If I were to find the slope between 2.9 and 3 of this function, that would be super close. Let's look at the black line. It's practically parallel. So the definition of the derivative is a way to say, okay, let's find the slope between the point we want to find the derivative at and a point infinitely close to it using a limit. So there are two formulas you have to know. The first one literally just does what I was just talking about. Let's say I have the function f of x equals, we'll do a very basic one, x squared plus 2x. And I want to find the slope, or the instantaneous rate of change, or derivative. All these are the same thing. Or dy dx at x equals, let's find it at x equals 2. So if we use the power rule, we already know the answer. It's 2x plus 2. You plug in 2, so 6. But we're trying to remember the formulas for how to do this. So the first one is called the derivative at a point. How do you find the derivative at a point? Use the formula, which is literally the slope formula. And it looks like this. To find the derivative at the point A, in this example we're about to do, it's going to be 2. You take the limit as x approaches a of the function minus f of a over x minus a. So in other words, you're saying if I have the slope between a point x and the point a, and I want to figure out the derivative, you're basically saying what's happening when x and a are essentially on top of each other. So it's the instantaneous rate of change at the point. So at this point, you can plug in. So we're going to do our example from above. F of x is always the function, so x squared plus 2x minus f of a is what you get when you plug 2 into the function. So 4 plus 4 is 8, all over x minus the a value, which is 2. At this point, this is where the fun is, because something's always going to cancel when you're dealing with a polynomial function. Always. If it doesn't, you did something wrong. Always has to cancel. So I know it's going to be x minus 2, and then it's probably going to be something like x plus 4, all over x minus 2. You get to cancel, and then, oops, sorry, not a. At this point, a is 2. Let me fix that. 2, 2. Now you can plug in 2 plus 4 is 6, just like we thought. So this was the derivative at a point. It finds the instantaneous rate of change at the point by using the derivative at a point formula. This was the less impressive of the two because it only finds derivative at a point. It's a lot of work just to get one answer, because now what if I did the same problem and said find the derivative at 3? You'd have to do all the work again. So there was a better formula we learned, and that was the second one. I'm actually going to do a different example. It was finding the derivative function. Find the derivative as a function. Now, in the old videos, I really go through where this comes from, and I still think that's important. However, just for the sake of time, because we have so much to get to, I'm not going to go back into why this works the way it does. But the same logic. You're basically finding the slope between 2 points that are infinitely close to each other. It's a little bit different because this one has h in it. Essentially, you're just finding a point, and then you're finding a point h away from that point, h units, and you're setting h as it approaches 0. So same idea. You're finding the slope between 2 infinitely close together points. The formula looks like this. To find the derivative function this time, not the derivative at a point, but the actual derivative function. The limit as h approaches 0, f of x plus h. You plug x plus h into the function, minus the original function, all over h. And this one has a lot more work to it, but it gives you the derivative function. So let's do an example. I'll give you the function. Let's do a radical one. And let's find f prime of x. Let's find the derivative. All right, so you need to set up the equation using the formula. Limit as h approaches 0. F of x plus h. That means everywhere you see an x in the problem, you plug in x plus h. Minus the original function, all over h. That's the setup. You need to be familiar with what these setups look like. So look, in the future, I'm going to start you here, and you're supposed to recognize that this is the definition of the derivative, and you're supposed to realize that this is what's plugged into it. This is the function. So this back piece is always the function. We will practice some multiple choice on this soon, because I know the AP test loves to ask this question. So we're going to evaluate it, but most of the time we're not going to do this by hand because we have shortcuts that are way faster than this. But we're going to use a conjugate. In theory, you could use L'Hopital rule here, but don't, because it doesn't. It's a little weird to use L'Hopital's rule to find a derivative, in a limit problem involving a derivative when you're finding a derivative. Like, it just doesn't make sense. This is the definition of the derivative. You're supposed to do this when you don't know how to find derivatives, so why would you take the derivative of the problem? It's just, don't do it, okay? When we get to the AP test, fine, but I actually want to see you doing the conjugate. So you multiply these two together. I have way more examples of these in the other videos. Roots cancel. 0 with x plus h minus 2. The middle terms cancel, so that one would cancel, that one would cancel with each other. And then this times this, then roots cancel, but don't forget the negative. Do not multiply the bottom together. Keep the h out, because the goal is to cancel the h. Goal is to cancel the h. And let's see what happens. Everything in the top should cancel. That's the fun part too. So this x cancels with this minus x. This negative 2 cancels with this positive 2. And you are left with just the h up top. So all of this is gone. I'll leave the h here. But then the h cancels also. And now you can plug in. So it looks like we only have a 1 in the numerator. All over. Plug in 0. You get x minus 2 plus another rad x minus 2. When you're adding radicals, there are 2 of them. And that's the answer. And we know that because we could take the derivative using our shortcuts. Remember, right? This is x minus 2 to the 1/2. And that's chain rule. So 1/2 x minus 2 to the negative 1/2 times the derivative of the inside, which is just 1, so we don't have to worry about that right now. And then the negative exponent means it goes to the denominator. And lo and behold, we have the same answer. Okay. In class, we're going to work on a more complicated one that I'm not going to show you right now, but in class, we're going to do rational functions. So for example, if I start you here, can you go through the algebra to find me the derivative? Using the definition of the derivative, it's tricky, but we'll work on that. But the one I care about the most, okay, so just watch. This is the most important part. I want you to watch this part. I'm going to ask you about this on the next day, and we're going to talk, because this is the one that, this is why we're doing this whole lesson again, because we have all these shortcuts now. There's really no reason to go back to the definition of the derivative at this point. But let's say I gave you e to the 2x. Oh, the dogs are barking. She's like old times. And I asked you to find f prime of x using the definition of the derivative. And then after that, I asked you to find it at x equals, let's say, 2. All right, let's set up the equation. Set it up. So we use our formula, limit, h approaches 0, find the derivative. We take f of x plus h. So in other words, everywhere you see an x, you plug in x plus h minus the original function all over h. Okay, your goal is not to do any more work than this. We have just set up the equation. Now the other thing, if I wanted you to find the derivative at 2, what we do in the other problems is we simplify this. So if we go back to this problem, for example, now if I were to go here, we have the derivative function. I could ask you to find f prime of 3, and you would just plug 3 in. Well, the trickiness here is we're not going to do any work, but we're still going to plug 2 into the derivative equation that we've set up. So e to the 2 parentheses 2 plus h minus e to the 4 all over h. And that's as far as I want you to go for the homework. Here's why. Down the road and on multiple choice, they're going to start you with this. They're going to say something along the lines of, hey, the limit as h approaches 0 of e to the 2 times 2 plus h minus e to the 4 all over h equals what? And if you just start there, it's very confusing. It's kind of like, well, it is like they're starting you in the middle of the problem. You're going to need to recognize, oh, this is the definition of the derivative. So your 2 parts that you need to find are the original function, and you need to find where they want you to evaluate it at. So to find the function, look here, and it looks like, oh, look, it's e2, and then this is x plus h, and right there, there's the x value they're plugging in. So I know x is 2, and I know that the function is e to the 2x. So what is this question asking, really? It's just asking what's the derivative of this function here. So they're saying, what's the derivative of this function? Well, we can do the chain rule. It's 2e to the 2x. And then plug in 2. Answer, 2e to the 4. Done. So that's what this equals. It's a little confusing, but it's a free point if you know what you're looking for. You just need to recognize that whenever you see this h business with h approaching 0 and h in the denominator, it's the definition of the derivative. Find the function they're plugging in, find the x value they're plugging in, extract or take that out, extract it, and then just do the derivative using our shortcuts, because you're not going to be able to evaluate this by hand. I mean, again, you can use L'Hopital's rule, but the better way is just to recognize that, oh, look, I know that the function is e to the 2x. I know they're asking me to find the derivative at 2. Okay, so this problem is probably the most important out of all of these, because you're not going to be doing derivatives by hand like this pretty much ever. But early on in this class, I'll have you do a few. All right, that's it for now. Bye.